Okay, we're going to verify that we have solutions to DEs. Remember, when we're solving a DE, our goal was to find a function that satisfies the DE. We're not trying to find a number. Our solution is an entire function. So we have this differential equation. This is an ordinary linear differential equation. First order, we only have first derivative. Somebody suggests that this function is a solution. There could be many, but we think this may be a solution to this DE. We're not told an interval. Remember, solutions exist on intervals. Here, this function is continuous for all real numbers, so this solution will actually work for the entire real number line. Okay, so we want to verify this is a solution. So I've got a y prime here. I'm going to need to take the derivative. So the derivative of anything, e to the anything, is e to that same thing times the derivative of the top, chain rule. Derivative of negative x over 2 is negative 1/2. Now we substitute y prime and y, whatever we need, back into the DE. So twice y prime plus y, we want to know question mark, does that in fact equal 0 like the DE says it does? Well, here the 2's cancel. These are like terms and they cancel out. We do in fact get 0. So this is a solution to the DE. Okay, here's a more complicated one. Much more complicated. I want to verify that this nasty looking thing is a solution to this second order linear differential equation with constant coefficients, by the way. My coefficients here are 1, negative 6, and 13. This is second order. It is linear because I don't have any nonlinear version of y. No y squareds, no e to the y, no cosine of y. Okay, my DE has a y prime and a y double prime in it, so I'll need to find both of those. In order to get y prime, I'm going to have to chain rule this, so you should verify this is y prime on your own. And then to get y double prime, I'm going to have to product rule and chain rule. I'm going to have to use product rule and chain rule again here. So verify this on your own, that this is the second derivative. Be careful with that negative. You will have to distribute that negative. Now we plug this in for y prime, this in for y double prime, and this in for y, all into the original. So y double prime minus 6y prime, and there should be parentheses. I think I'm missing a parenthesis. Right here, there should be an extra parenthesis. Check that on your own. Plus 13 times y, we want to know question mark, does that equal 0? Well, when we do all of our distributing, let's check one of these. Let's check the cosines. I've got 9 of these cosine terms, minus 4, so that would be 5, minus 18 more, so that's negative 13 of the cosine terms, plus 13 of the cosine terms. Those all cancel out. Check on your own. The sine terms also cancel out. So this function here is a solution to this DE.